Okay, the next session we're going to be talking about are the physical properties of alcohols and ethers. Notice with this example, there's an ether right here because it's an oxygen surrounded by a carbon and another carbon, and here's an OH group for the alcohol. So when you're determining the classification of an alcohol, one of the things you want to look at is how many other carbons it's bonded to. So here's your alcohol. What I would do in order to help yourself with this is to circle the alcohol and the carbon it's bonded to. You'll notice that it has 3 other bonds this carbon can bond to. This particular one is a hydrogen, and a carbon. We're going to count the carbon groups that it's attached to. Since it's bonded to one carbon group, it's a primary alcohol. Whereas this one, circle the OH and the carbon it's bonded to. Look at the carbon it's bonded to. Here's a carbon group here and a carbon group here. That's making it 2 groups, which is making it a secondary alcohol. And then finally, circle the carbon in the OH group. And then it's bonded to 3 different carbon groups, which is making it tertiary. Now, it doesn't matter how big the chain is after that. For instance, if you have a COH, and then you have a hydrogen here, and you have a carbon, but this carbon is 3 carbons long. This whole thing is considered one group. So this is actually a primary alcohol. Don't say that just because there's 3 carbons here is tertiary, because it has to be bonded to that same carbon. So let's take a look at these. Circle the carbon in the OH group. We have a carbon on the left and one on the right. That means there's 2 of them, which means it's secondary. Here's this one. We have 1 carbon on the left and none other ones. So it's primary. And finally, there's our OH group and carbon. Here's a carbon here, here, and here. There's 3 groups, which is making it tertiary. Now, ordinarily, carbon-hydrogen compounds are nonpolar. They have extremely close electronegativities, which is making them not want to react in water. However, this oxygen, when we're looking at the periodic table, here's fluorine, here's oxygen right next to it. Oxygen is extremely electronegative in comparison to carbon, which is over here. That means the electrons are drifting from the carbon towards the oxygen, and same with the hydrogen. That's making the oxygen more negative, which is why we have that partially negative sign. Now, this negative-positive interaction here will then interact with the water. So this negative is being attracted to the positive part of the water, and this positive is being attracted to the negative part of the water. This attraction is called hydrogen bonds. So hydrogen bond isn't an actual bond. A hydrogen bond is an attraction between positives and negatives. And hydrogen just is involved in that attraction. That's why they're referred to as hydrogen. Now that means at some point, because of this nonpolar area here, it's only attracted if there is enough, if the carbon chain isn't too long. Think of 4 being the cutoff. So more than 4 carbons, and there's no attraction, which means it's going to be insoluble. Less than 4 will be soluble. So that's why when we're looking at this, 1 to 3 carbons are soluble. That's talking about carbon, 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 OH. That's going to dissolve in water. However, when you reach 4 4 is only going to slightly dissolve. So it's slightly soluble. And then 5 and up is actually insoluble. There's actually similarities with the ether. There is some electronegativity here. However, the hydrogen bonds are far weaker. Remember, this is an attraction. It's not a real bond. Once again, we're going to say that the cutoff is 4. However, with ethers, they're only slightly soluble. That's because with alcohol, you have an OH group here and a carbon here. Well, the oxygen can overpower the hydrogen very easily because it only has 1 electron and 1 proton. It doesn't have much to fight back with. Whereas with an ether, there's still an attraction there, but it's not nearly as strong because the carbon can resist oxygen's pull more than the hydrogen can. So this partially negative is actually lesser than the partially negative of OH. And once again, 4 is going to be the cutoff. More than 4 and it's not going to be soluble at all. Less than 4 and under will be slightly soluble. So if we look at these, 1 through 3, notice 4 being the cutoff, is soluble. And these are all alcohols. These are not ethers. At 4, it becomes slightly, it'll dissolve a little bit, but not all the way. And once you hit 5, it's completely insoluble. It's just going to sit there. Phenols are similar. They're only slightly soluble. So ethers and phenols are only slightly soluble, whereas alcohols are soluble up until you get to the 4th one. It can form hydrogen bonds because of the OH group, and that's about the extent of it. So let's take a look at whether or not these will be soluble. There are a lot of carbons here. Remember, 4 is the cutoff. There's so many there that it's insoluble. Here's B. There's 1 on the left, 2 more on the right, so we have a total of 3. 4 is the cutoff, so this is slightly. It's only slightly because it's an ether, not an alcohol. Alcohols are soluble with 1, 2, and 3. Ethers are only slightly soluble with 1 through 4. And then we have 2 carbons with an OH group, so we have an alcohol with less than 4. That's going to make it soluble. And that is the physical properties of alcohols and ethers.